All right. So what I want to do today is kind of get through the rest of the rules for dealing with pointers in C. So knowing the rules is not the same as being to apply them, of course, but that is a first step. So we are over here. So this is like, again, kind of coming back. This is one of the more difficult items in ESC190 as well, obviously. Hopefully, we'll get there at the end. So I try to make kind of parallel structures that are kind of in C and in Python. So first of all, that was the first question on the quiz that you did not see. So if you copy the value into don't change int, you copied the value, there's absolutely no way that saying a equals 42 can have any effect outside the function. A is a local variable. You copied some value into a, you can change the copied value, but there's nothing you can do outside the function. In Python, in a way, there is nothing that's equivalent to that. We'll see something that looks equivalent in Python. So in fact, the third one is kind of related, and that's the equivalent of what you would think of in Python when you're sending a to a function, right? So when you're sending any value in Python to a function, what you are really sending is the address of the value. So over here, what I'm doing is I'm sending the address PA to don't change PA. And I'm saying now PA used to be the address of something. And now I'll set that address to 0, not the value at the address, but the address. So I wrote down PA 2028 on my note, and now I crossed it out and I wrote a new office number. That didn't change the contents of my office, right? So this is this, and this is the equivalent of what happened in Python, right? So in Python, you sent a, which means you sent an address where there is a value. And now you're saying, instead, I want a to be the address of 42. That's always what happens in Python, right? So the Python a equals 42 kind of looks like the C one at the top. And at the end of the day, they do the same thing, right? So it might be that you don't care so much about the difference right here, but really the equivalence here is the third line. The first one just doesn't have an equivalent because in Python, you never copy a value when you send something to a function. You always send an address, right? But you change the address. In C, same as in Python, that does not have an effect outside the function. So in C, we have the second thing, which I'll kind of show you for fun, a thing in Python that kind of does it, but basically we don't have in Python. And that is, I can send the address PA to a C function, and that function can say, I'm going to go to that address and I'm going to change the value at that address. So if I sent you the address ban 2028, and then you went to my office and you changed something there, well, that has an effect in my office. I might be overdoing this analogy. So, but that's exactly it, right? As promised, I wrote up something just to show you that you can do stuff. So this is not something that would work, that is guaranteed to work on any computer. It happens to work on mine. And basically what it does is this deref function takes an address. Python functions always take an address, but in this case, we're sending like ID of A. And it takes the type of the value. And then what it returns is an actual computer address that you can modify. So here, in fact, change A would work. So I make A be like 59,000, and then I send A to change A. This does whatever magic it does. It doesn't matter. It's not guaranteed to work on your computer anyways, but on mine it does. And here you have it, A is equal to 43. So there's not, again, don't do this. It's not safe. It could crash the computer, but it happens to work on mine, so you can technically do it. Yes?
I'm curious why you're indexing the dereference at 6.
That's because the integer is not just an integer. It also has kind of all sorts of stuff, all sorts of junk in front of it. For example, how many digits. So in order to actually change the value, I need to like go forward. But the direct answer is I copied it from Stack Overflow. That's what it said. But both are correct reasons. So anyway, you can do something even more fun here. So maybe I want to change the value of 42. And then maybe I want to print 42 because I want to know the value of 42. And the value of 42 is now 43. Yeah.
Is that because like the first 100 numbers are...
No, it works with anything. So it's because in Python, I entered 42 the literal, and Python, well, 42, you're right, it's preloaded, but either way, with 59,000, it would be that the literal 42 lives at some address. And then change A went to that address and wrote 43 to where 42 lives. So now if I say print 42, I go to the address where 42 lives and I print the value of 42, and it's 43 now.
Is that just in your Python's memory table, or is that in your...
In Python, the memory table is not just like Python specific, it's specific to the program that's running. Yeah.
So is this what you do by Python always passes in a parameter 42, you're not like...
That's right. That's right. So when I say print 42, what I'm actually saying is send the address where this thing lives. I don't know that it should be called 42 anymore, but take the address where this thing lives and print the value at that address. That's the instruction to print. All right. So that's kind of fun. But obviously, like not on the exam, just like, you know. So okay. This, however, is on the exam. So the official thing is like, it's not like this trick is not guaranteed to work. And in fact, like if you try it on your computer, like there's no guarantee that it would not crash. So, okay. So what about lists? So in Python, you send a list to change L and you say L at 0 equals 5. Well, that puts 5 in the one list L, so that has an effect outside the function. In C, that's the same thing. So you send int star array, so that means you send the address of the first element of the array, and you're saying, go to that address and change the first element to something else. That will have an effect outside the function. On the other hand, in Python as in C, you say, I want the local variable L to be something new. Well, that changes what the local variable L refers to. It does not change anything else. Similarly here, I say array equals 0. That changes the local variable array. So again, I sent a note that had the address of the first element, and then I scratched it out and wrote something else on the note. Okay, that changed the note. It didn't change the contents of that address. What about strings? So in Python, there is, again, kind of, you can look up ways on Stack Overflow that might not work. But there is, like, you're not supposed to be changing the contents of a string in Python, right? You can I'll make that distinction now. So, and we've made it before as well. So you can say like S is ABC, and then you can say S is whatever, S plus D. That's fine. But that's not changing the contents of S, right? This is saying make a new string whose value is S plus D, and then reassign that to S, right? The reason this is an important distinction is that you do this inside the function and the local variable S changes, that has absolutely no effect outside the function because you're making a new thing and putting it into S, right? So that's, again, the distinction between this kind of thing, which can change something outside the function, and this kind of thing, which cannot. There is also efficiency implications. So if you're making a really large string all from scratch, that could take a lot of time. Make sense? Questions? All right. So in C, if you're using a const char star, that's kind of the same as having a Python string in that the compiler is just not going to allow you to try to change the contents, right? So you try to say s at 0 equals x. What's going to happen is it's not going to compile. So it's not going to be a runtime error. It's not going to give you a program to run because that's against the rules, right? On the other hand, const char star, you can change what array is. You can say array is now 0, and fine, the local variable array is now 0, has no effect outside the function, but that will compile. That's similar in spirit to the Python don't change s, where you had s, which was an address of some string, and now you say s is the address of this new string. Right. So the difference here is I cannot say like array is well, depending on how you do it, you can say array is actually like in C you can actually input ABC here as well. I chose to do 0. Yes.
I think I remember you said earlier that strings are just class char star type. Right?
That's correct.
Right.
Yeah, that next slide. Yeah.
Oh.
Yeah. So thank you. Great minds. Thanks a lot. Thank a lot. So if you send a char star s, that's the same as sending an int star array. You go to the address f, you can change the first element, no problem. Right. Now, a problem that might come up if you do this kind of thing is this. So if you say S1, I didn't put a type here, but char star S1 is equal to ABC, and then you say change array S1, that's going to compile, right? And that's because you said, okay, like S1 is a char star, so it's an address of a char. You can go to that address and change it. But the right-hand side is actually a constant. So C is going to give you a warning when you're doing char star S1 equals ABC. Hey, like you're converting a const char star to just a char star. But it's going to let it slide. And then if you then go and try to modify this A inside the function, it might or might not turn your computer on fire. Well, probably not. But anything could happen. So this is what's called in C, that's like the technical term that everyone uses, is undefined behavior. So for example, changing the value of the contents of a const char star is undefined behavior, which means that the C compiler is not guaranteeing that anything in particular is going to happen. So if there is a functionality in your computer to self-inflame, it is allowed to do that according to the standards of the C programming language. More relevantly to you, what sometimes happens is it'll let it slide and it'll work. The problem is that it's not guaranteed to work every time, and it's certainly not guaranteed to work on a different computer. So for example, it might work locally on your laptop, but then it could crash on Gradescope. That would be very annoying. So we have tools to try to detect those kinds of issues. The obvious thing to do is don't ignore warnings. If C is warning you, it's probably right. So, okay, and this would get you a warning if you try to compile it. This, on the other hand, is completely okay, right? So here, S2 is an array. You can change the first element of the array to something else, completely fine. None of that exists in Python because there is no way to try. So, I mean, you can technically type stuff in, right? So you can say s at 0 equals x, but that will just produce an error immediately because that makes no sense in Python. Make sense? That just doesn't exist. You try, it doesn't work. So, okay. Questions about this stuff? All right, so I'm going to take a break from talking about rules and do an example from last week's lab and maybe go a little bit further than that. So to remind you, strlen is the length of a string. So that actually exists as a library function in C as well, but just for the sake of practice, we are now implementing it, right? So what is strlen asking you? If I give you a string that starts at 1032, so that would look like, for example, H and then I and then the null, then the answer is 2, because there's 2 steps where you start with H up until the point where you get to the null character. All right, so let's write this. By the way, the solutions I also posted to the website. To be honest, like in the beginning of ESC190, you don't need the lab solutions because ChatGPT can solve the labs. But kind of later on, like in a couple of weeks, we'll get to labs that ChatGPT cannot reliably solve. Of course, that's assuming that OpenAI doesn't up its game up until February, which it might. So no. It's the other. So there's a person crossing themselves. It's the other way. So like, if you're planning to get paid as someone who writes software, what you hope is that ChatGPT hits a plateau. So okay. So this would be my strlen. So I'm including stdio. Yeah, well, that's yeah. So main, and I'll define my str, and that would be hi. And now I want to print the length of the string, like so. So I'm going to do something different. So here, in order to, that would not actually give a warning, but here I would get a warning if I don't say const char, so I might as well say that this is a const char. So here's kind of, I think, the most straightforward thing. So I'll say, okay, so initially the length is 0, and then I'll check, is it a null? If not, I'll continue. If not, and so on, right? So I'll say, while str at len is not equal to null, so in C, you can say len plus plus, and that's the same as len equals to length plus 1. And then just syntactic sugar for length is equal to length plus 1. And now, so there is a bit of a problem here, which is, so if str at 0 is equal to null right away, then what I want to do is I want to return 0. And it indeed would, because I would never increase length. And then if the length is 1, then the same. So I would advance once. So the 1, 0 problem is okay. So I can just say return length. So syntactic. All right. Does anyone see? Oh, state. So, okay. So you can do it like that. So I'll write it a couple more ways. So one thing I might like to do is I might like to say, okay, I don't want to have an, so I don't want to do like str at len. So here is another thing I can do. Going on there. So again, initially length is 0. And now what I'll do, yes, that is what I want to do, is I want to say if star str is not null, I'll just advance star str, right? So the way I'll do it is I'll just say str plus plus, so that's the same as str equals str plus 1. So what this means is str initially is 1032, and then str plus 1 is 1033, and then str plus 1 again is 1034, and that's where I'll stop. Does that make sense? Hold on. Okay, that's not to do with me. Okay. So basically, instead of doing str at len, which is kind of an extra addition operation anyway, I'll just say, okay, I'll keep advancing str, and I'll just check, is the value at address str a null now? If not, go to the next cell, meaning increase the address str by 1. Does that make sense to everyone? Cool. So something you'll see quite often, and I won't do it a lot because it's kind of annoying, but it's worth seeing the ones because maybe the first time it's kind of fun, is you can make this thing really, really concise. So this would rely on 2 things. So first, not equal to null is the same, so or rather x not equals to null is the same as x when treated as a Boolean. And that's just because, like, this is just basically x is not equal to 0. And then anything that's not equal to 0 is true. So that means saying this and saying this when it's a Boolean is the same. So when it's inside the condition. Does that make sense to people? So the other thing is that in C, the value of A is equal to B is B. Copilot was lying just then. It's not the same as A equals to B. So So you can say A equals B, and that thing itself has a value. Right? So I can say something like A is C equals 3. And the effect of that is first set C to 3, and then set A to 3 as well. Third, the value, similarly, actually, the value of A++ is 8, and it has the effect of increasing A by 1, incrementing. So if you know about the programming language C++, that's why. So C++ is not just C++, it's actually make C be equal to C++. So, okay. So that means that something like int A equals 3, int B equals 4, and then B is equal to A++ means set B to 4 and set, well, that's unfortunate, set A to 6 and set B to 5. And before A was 5. Right? So with all of those things, which I'm not asking you to memorize, you can do something like that. So here, what we're saying, I'll do parentheses here, even though they're not necessary. So what's going on here is basically the same as this. Except what we're doing is we're saying while str is not equal to 0, and also, by the way, increment str by 1 after you're done comparing str to 0, the value at str to 0. Keep incrementing length by 1. So I'll always use the curly braces, but if it's a one-liner, it's not necessary. So this is saying, again, while star str is not equal to 0, this is what this is saying. So it's the same as this. And also, after you're done comparing str to 0, increment str. And then inside the loop, just increment length. So I'm just showing it to you the once. I'm not going to code like this. I don't suggest that you do either. It's not as if anyone's going to run out of disk space writing longer C programs, and trying to do this is kind of just showing off. With that said, if you read kind of the Kernighan and Ritchie textbook, which is like recommended but not required, they do this kind of stuff a lot. Part of it is like that was just the culture, as people like doing those things. And maybe paid more attention to a kind of aesthetics as opposed to maintainability. So that's that. So that is me criticizing my betters. So that's another way of doing it. The fun has ended here. Now we are back to actually doing stuff that is conceivably relevant to be, well, like this might also be relevant just because you'll see all sorts of code if you actually maintain C code, right? So you shouldn't write this, but your coworker who wasn't yet fired might. So, okay. So, all right, so let's do a recursive strlen. Not fun either. Instructive. Well, like if you're an exile, of course, you think instructive is the same thing as fun, unless we beat it out of you last semester. Okay. So how to do that? Don't tell me. So basically, what's the base case? The base case is str is null, right? So if the first thing that you see is null, then length is 0, right? Like if you're giving a string and it's just a null, that means it's an empty string because it's the terminator character right away. What's the recursive step? Well, so if you step once more, then what you can say is, well, the entire string is 1 plus the length of the rest of the string. Does that make sense? So that's like that. So let me type in case people are also typing. So we're sending the address of the next element of the string and saying, what's the length of the string starting from the next address? And strlen_rec is going to kind of magically figure it out through kind of the leap of faith thing. And then we're saying, well, what's the overall length? It's the character that we just skipped plus the length of the rest. Make sense? Question? Okay. So that's like that. And we'll ask, is str equal to null? And if it is, by the way, I'm trying to be consistent and failing. So in KNR style, the braces go on the next line for functions, but not for if statements and while loops. C doesn't care about it. I'm just trying to be consistent, not consistency so apparently. So if we are currently at the null, that means that the length of the string that we just got sent is 0. If we are not at the null, then skip the current character and give me the length of the tail of the string. Right? So to make it maybe too much, so what's the length of this? Well, so if this is like 1, 2, 3, 4, 5, 6, 7, so the length of this string is the length of the string that starts at 2 plus 1. And that's what we're saying here. So give me the length of the string that starts at this address plus 1, and then add 1 more because we skipped the first element. Is that making sense? Questions? All right. So there's going to be more practice with that in the lab today. So the last thing I want to talk about is malloc. So malloc is a way to create blocks of memory where you can store elements. So similarly to arrays, but with a difference. So local arrays are, local variables. They disappear after the function has finished running. So that means you cannot return an array from a function, for example, because you can return the address where the array used to be, but once you return, it's not there anymore. Arrays are also not resizable. So once you've set the size of the array, you're done. Malloc, on the other hand, doesn't have those constraints. So here's how malloc works. So malloc is a function. So you need, by the way, to include stdlib. So malloc takes the number of cells in the memory table that you want to take up in total, and it returns the address of your block that you can then use. So the usual way that we use it is like this. So we tell it we want, for example, 150 integers. So that means that we want size of n times 150. So as many cells as one integer takes up times 150. So we tell malloc, give me an address where I can store this many memory cells, where I can access this many memory cells. So then block end is going to be that address. So block end ordinarily would have a type. So if I'm storing integers, it would be address of integer. If I'm storing characters, it would be address of character. So in this case, I said int star. So block end is going to be of type int star. It's going to store the address of the first element of this block that malloc found that you can use. So because malloc by itself, it just gets a number. It doesn't know that you want integers, right? All it gets is this number size of n times 150, which is a number, not to do with integers. So in order to avoid the warning, what you want to do is you want to cast the value that malloc returns into a type int star, because malloc, it could be that it doesn't know if you want integers or chars or what. You know what you want. So for that reason, on the left-hand side, you say, I'm intending for this to be an address of an integer, and you cast the return value of malloc into int star, because malloc does not know. Malloc just gets the number of memory cells. And we computed the number of memory cells that we needed manually when we said size of int times 150. So after you've done it, you can do whatever you want. So you can do like block int at 7 equals 42, and that stores 42 at element 7. Yes. Sorry, with the noise and the masking. Undefined behavior. Again, the computer could be on fire. Okay. And block int at 7, like we saw last time, it's the same as star block int plus 7. And that's just because what C does when it sees this is it just converts it to this. That's the first thing that happens. It's just syntactic sugar. So here's a picture of what that would look like. So imagine, that's not usually the situation actually, but imagine that an int takes up 2 memory cells. On modern computers, it would be 4. Okay, so that means that, for example, 5 is stored in like 1032, 1033, and then 7 is at 1034, 1035. Right? So block int plus 1, because block int is an int star, C knows that block int plus 1 means skip to the next thing in the block, not to the next address. So if it knows that an int takes up 2 spaces, it'll skip from 1032 to 1034. And that happens automatically, right? The way to think about it is, think about this guy. Like this guy works, and it works the way you would think it would work based on Python. And then because this guy is actually star block int plus 1, well, it does what it has to do in order for that to work. Does that make sense? Okay. So just for completeness, size off, we kind of did it informally. So I'll give you the usual values. It's not necessarily the case that those are the values that you'll see. Well, on your computers, like pretty sure, unless like someone here running like Raspberry Pi or something. I don't know, but other than that, that is what it would be. But when you're writing code, if you want it to work in the future, and if you want it to work on old hardware and stuff, well, you don't hard code those values, but I'll tell you what they are. So int usually is 4. Char is an exception. That must be 1. That's just in the language definition. And then char star, int star. So those are address of char and address of int. In practice, those are stored the same way. Usually not always. So cells, we haven't done bits and bytes yet, at least formally. So kind of by bytes, I mean cells. So usually 8. Actually, this is the kind of thing that changed not quite that far, not quite a long time ago. So actually on Mac, I think especially, you still get to sometimes choose, do you want the 32-bit or do you want the 64-bit? And actually this has to do with the sizes of the car star and star on a particular computer. So we'll do bits and bytes later, but just kind of as a preview, that's what size up does. Yes?
If you do size up, but you input an array, not the word
Yes.
star, but
Yeah, you don't need to ask. It's like always on the next slide. So with arrays, what you get is the total amount of space that all the elements of the array take up. So size of array is, if it's an array of integers, is size of int times how many elements there are in the array. So you can get the length of the array by doing size of array divided by size of array at 0, for example. So one common way for people to mess it up is this. So you define an array somewhere, for example, in main. So here I say the array A is 1, 2, 3. Inside of main, the size of the array would be size of int times 3, so 12. However, anytime that you use A, the first thing that happens is it gets converted to the address of the first element. So when you send A to SZ, what you're sending is not an array. What you're sending is the address of the first element. Always, except for size of, it gets converted to the address. So that means that inside of SZ, you try size of A, and the answer is going to be 8. Because an address takes up 8 bytes. Yes.
All right. I think that's where I'm so confused. How would passing in size of array, can they go to the same kind of while with strings?
No. So yeah. So with strings, we wrote strlen because the convention for strings is that the null means that the string is ended. Arrays don't have a convention like that. You could if you wanted to. Right? So you could, well, it's just that by default, like they don't, there's no convention, but you could make, if you wanted, you could make your own convention and say, I want to denote the end of my array with whatever special value. It's better not be 0 because then you can't store regular zeros. But you can say whatever, like the largest possible integer, I'll just like not ever use it. I'll instead use it as a terminator. And you can do it. People usually don't because if the array is small, then that means that you're using extra space. If the array is very large, then to find out the length, you actually need to go to the end. So that's not worth it. With strings, the trade-off is a little bit different because you want to be able to like print the string and stuff. So you don't want to be passing the length of the string all the time. You could imagine a different trade-off. It's just that usually it's not that. So you can do the same thing with structs. So if you define a struct, you can say size of string, and that's going to tell you how many memory cells does this entire thing take up. Okay, we'll do an example next time. I will see you. Bye. Thank you.